Okay, this lesson is section 7.3, proving triangles similar. So let's talk about what similar triangles are. Okay, similar triangles. Two triangles are similar if and only if the corresponding angles are congruent and corresponding side lengths are proportional. Similar, what does that mean? That means that they are the same shape but different sizes. So last time we talked about a dilation, which produces similar shapes. You're doing an enlargement or a reduction. The shape stays the same, but the sizes change. That is what similar shapes are. Okay, we're going to focus on triangles, but it works for all similar shapes. Corresponding angles are congruent. Corresponding sides are proportional. Okay, that's what it means. And so what we're going to be doing is there's some, just like we had congruence properties for showing triangles are congruent, there are similarity properties, and here is some of them. So the first one is angle-angle similarity. Angle-angle similarity. Angle-angle similarity, this shape right here. This is the minimum amount of information you need to show the two triangles will be similar. Okay? All I need is two angles. If two angles in one triangle are congruent to the corresponding two angles in the other triangle, then the two triangles are similar. That's what that means. The other one is side-side-side similarity. If I have three sides, if the corresponding sides of two triangles are proportional, then the two triangles are similar. So if I can show some proportionality between the side lengths, like in these proportions right here, then I know the two triangles will be similar. The naming is the same. You need to name the corresponding parts in the same order, so be careful when you name these things also. The third one is side-angle-side similarity. So if you notice, there's a little tilde on the back end of these things so that we don't confuse them with the congruence properties. These are for similarity. So side-angle-side, just as it says, what I need is the angle of one triangle is congruent to an angle in the other second triangle, and the sides that include the two angles are proportional, which means if I have that angle, I need to have this side, and this side, and this side being proportional. Okay, so it becomes side, angle, side. Okay, if I have that, then I know the two triangles are similar. So these are the properties you're going to want to have available to yourself in your notes, on your note cards. And so let's go do some problems together. There's only a couple of examples. And so here we go. Here is the first one. Is triangle ADE similar to triangle ABD? So let's trace it out. ABE. So they're talking about this triangle here on the end. Is this one similar to ABD? Is this triangle similar to this triangle? Okay. And at first glance, you might say no, they don't, maybe not, but I haven't drawn anything to scale, so you can't go by what it looks like. What I do notice is that this is an isosceles triangle, and this is an isosceles triangle. So there's a possible potential here. So what we need to do is we need to look at this and see if we can't figure out a way to determine if this is indeed similar. So what I know, if they're similar, is that corresponding angles are congruent, okay, and corresponding sides are proportional. Now, I don't have a lot of angles in here, but I do have a lot of side lengths. I have all three side lengths here. I have all three side lengths here. So we're going to test it out by the proportionality of things. So we're going to take corresponding parts. Okay, that would be AE corresponds to AD. So, and the other one would be AB corresponding to AD. So as long as we take them in the same order, we should be fine. So let's take AB and AD, and let's see what we get. In this particular case right here, AB is a length of 3.2. AD is a length of 2.4. And so we can reduce this. And if you look at this as 32 and 24, we know that 8 goes into both of them. So this on top will be 0.4, this will be 0.3. which means this is 4/3. You can also use a calculator to help you reduce it. Now let's look at the other one. We can't just stop with 1. Let's see what I do. AD is this side for this triangle, right? For the big triangle, and this is for the little one, the corresponding part. Since I went AB to AD, I went the big triangle to the little triangle. I need to go from the big triangle to the little triangle again. The big triangle AD, the little triangle AE. You have to do it in the same order, or to make sure you can compare the number. If you do it out of order, you could get a different number. AD is 2.4. AE is 1.8. Let's reduce this. This is an 8. So again, these can be reduced. And when I reduce these, both of them have a 6 in common. I get 4/3 again. Okay? So are these triangles similar? And since this side over here corresponds with this side and it's the same values as these, then yes, they do. And so then we can say yes, triangle ADE is similar to triangle ABD by side similarity. And that's how you would explain it. Okay? Part B, how about those two triangles? ADE, and EDC. Are these two triangles similar? Okay? Are those two triangles similar? So we do the same thing again. This is the long side of this triangle. This is the long side of this triangle. So we can do it again. We say, okay, well, AD is to ED, and that's 2.4 over 2.4, which is a 1. And then we take another side. This side corresponds with this side. So I did, so that'd be AE to DC. AE is 1.8. DC is 1.4. This is not equal to 1, so this is no. These are not similar triangles. Okay? Because the sides are not proportional. They have to be the same number. That is not a 1, and so it is not true. We have another example over here. Okay? So Avery puts up a 50-foot radio tower in his backyard. How long is the shadow of the tower? If Avery is 6 feet tall and casts a 5-foot shadow. So this is a classic example. The sun's up here, and so what happens is, because the angle of the sun is the same for both triangles, we have a congruent angle down here. Okay? And we also have congruent angles up here because of that. These are all vertical and these are horizontal. The shadow's on the ground. And so what I have here is I have similar triangles, and so are the sides, and so the sides must be proportional. And what I can do then is, when I set this up, is I set it up as proportions, and it has to be corresponding parts in the same position. I can do this several different ways, but one way to do it is to take this divided by that, so 6 over 5 must be equal to, and then the same positions over here, this over that, 50 over x. And that sets up my proportion. To solve a proportion and fraction equal to a fraction, you can cross multiply. That's where cross multiplication comes into play. Okay? And so when I do that, 6 times x must equal 5 times 50. I usually don't multiply this out, and I'll show you why here in just a minute. The next thing I do is I'm going to divide by 6. And so now I got x equals 5 times 50 divided by 6. And here's why I didn't multiply it out. Because these are smaller numbers, and I can see anything that might be able to be reduced. For example, these are both even, so I can divide 2 out of both of them. And then I'm multiplying by smaller numbers. 5 times 25, well, it's basically 5 quarters, so that's 125. And divide it by 3. Since everything in here is measured in feet, how long is the shadow? 125 divided by 3 feet. And you can leave it as a fraction. If you change it to a decimal, it's an approximation. It's no longer exact. So you can leave it just like this, as long as it's reduced. Okay? And so that's how I can use proportions. We'll do a lot more problems together in class. And so that's 7.3.